Okay, so today we're going over module 12.3. It's called using proportional relationships. So objective students will use proportional side ratios to solve for a missing side of a triangle. In this first part, we're going to be solving for the length of a flagpole. So we're using these two similar triangles. So what you have to do first is just, again, figure out what parts correspond to each other. So I know this side, the 5 feet, corresponds to the flagpole, the X, as well as the 3 feet on the bottom corresponds to the 20 feet right there. Okay, so when we set up our proportion, we make two fractions. We put 5 and X both on top. Okay, and then the 20 and the 3, they both go on the bottom, in the denominator. Okay, and then we just cross multiply here. So we start with the x's. X times 3 gives us 3x equals 5 times 20 gives us 100. Okay, and then there you're going to solve for x. So what we're going to do next is just divide by 3. Okay, so I'm going to divide 100 by 3. That's going to give me 33.3, I was going to say feet, which is the height of the flagpole. Example 2 is go over another one similar to this one. Again, we're finding the height of a flagpole. So here, you know, the 72 and the h correspond to each other. So when I put on my fraction, I'm going to put 72 equals h over, and another 48 is on the bottom. 128 is on the bottom as well, so I put 48 over 128. So here I'm just going to, again, cross multiply. I'm going to take 48 times h. So I'm going to get 48h equals, then I'll take 72 times 128. And that's going to give me 9,216. And I divide by 48. So it just always cancel out. So I get h equals 192. And the units here are in inches. So I'm going to say now 192 inches. Okay. Okay, so now this time to solve for the height of the palm tree. So here we're looking for the height of this palm tree. So since we don't know the height, let's call this height x. So I know the 1 and the x are going to go on both on the numerator. So I'll put 1 equals x and over. And then we take the other two sides, the 1.6 and the 7.2 go together. So I cross multiply x times 1.6, 1.6x, and I multiply 1 times 7.2, which gives me 7.2. And I'm going to divide 1.6 to both sides. So I divide by 1.2, 1.2. These eliminate. So I get an answer of x equals Now 7.2 divided by 1.2, that's going to give me 4.5. And the units here are in meters, so I'm going to say 4.5 meters. Example 4, similar to what we've been working on. It says here Liam is 6 feet tall. To find the height of a tree, he measures his shadow and then the tree's shadow. So the measurement of the two shadows are shown. Find the height of the tree. So again, Liam is 6 feet tall. We're looking for how tall the tree is. So I'm going to say 6 equals h, and over. And I know that 8 and the 28 go together. So these are the two proportional sides. So it'd be 8 and then 28. So here I have my proportion, my two ratios. So I'm going to, again, cross multiply. H times 8 gives me 8h. And I'm going to take 28 times 6. I'm going to multiply those two together. That gives me 168. Divide by 8. Eliminate. So I take 168 divided by 8. That's going to give me 21. So I'm going to say H equals 21 feet. Okay, example 5. Again, you're going to find here the length across the river. So think of this right here is the river, and these measurements are made. So what I do first is I'll figure out what parts go together. So I know this is the shortest side of the triangle, so let me know this part and 372 go together. And also know the 600 goes with the 400. Okay, so when I set up my proportion here, I'll take D equals D over, and I have 327 over. Okay, and then the next value, I know the 600 and the 400 go together, but since D and the 400 together, I'll put 400 under D, and then 327 and 600 together, so I'll put 600 over that. And I cross multiply here, so D times 600 gives me 600D equals, and I'm going to multiply 327 by 400. And that's going to give me a big number, but it's going to be 130,800. And what I'm going to do next, I'm going to take that number and divide it by 600. These eliminate. So I take 130,800 and I'll divide that by 600. And I'm going to get a value of 218 feet, which is the distance across the river. Okay, example 6, again, distance across the water, here the river. And again, what I do here is figure out the proportional ratio or sides. So I know the 24 and the 42 go together, which means that length D and 35 correspond with each other. Okay, so when I go up and set up my proportion here, I'll say D over 24 equals 35 over 42. And again, I cross multiply here. D times 42 gives me 42D. And then I multiply 35 times 24, which gives me 840. And I divide by 42. These eliminate. So 840 divided by 42 gives me 20. So that means the distance across the water here is 20 feet. Okay, so now we're going to be finding the geometric mean of two numbers. And this is how we set up the geometric mean. So it's still a proportion between these two values. So what we do here is I set up a fraction. So I'll put 4 over x equals x over 25. And then from there, I just cross multiply. So I'll take the x's first. So x times x gives me x squared equals, and then 4 times 25, that's going to give me 100. Now to get rid of a square, I'm going to square root both sides. So that and that eliminates. So I'm going to get x equals square root of 100 is 10. So this value I get here, we say that's the geometric mean. All right, let's practice this again. So I get geometric mean between 9 and 20. So I can think of it like 9 over x equals x over 20. We always want to have the x on opposite sides, one on bottom, one on top, numerator, denominator. So I can always start off by multiplying the x's together. So x times x gives me x squared. And I'm going to take 9 and 20. That's going to give me 180. Okay. All right, so now I take the square root of both sides. Okay. So these eliminate. I get x equals square root of 180. All right, so now I want to break this down, take the square root of it, see if I could reduce it some more. So what I'm going to do here is find perfect squares that go into 180. So two numbers that multiply by it is 36 and then 5. So 36 times 5 gives me 180. And I still break it down like this. So now square root of 36, this gives me a 6. Square root of 5, that stays the same. So I take square root of 5. So I say here x equals 6 times the square root of 5. And this right here is my geometric mean. Okay, 9. 6 and 24, so I'll take 6 over x equals x over 24. Again, cross multiply here. X times x gives me x squared. And I have 6 times 24, which gives me 144. So I'm going to take the square root of it. X and square root cancel each other out, eliminate each other. Now square root of 144, that's going to be 12. So this right here is my geometric and 10. The geometric mean of 5 and 12 again. So here, 5 over x equals x over 12. Again, cross multiply the x's first. X times x gives me x squared. 5 times 12, that gives me 60. Now I take the square root of it. Okay, now I want to find, so these eliminate. X equals square root of 60. So now I want to find a perfect square that goes into 60. So here the only number I could find is 4 and then 15. 4 times 15. So break this up like that, both under square root still. Square root of 4 gives me 2. 15, we can't take the square root of it, so I'd leave it as square root of 15. So again, this right here is my geometric mean. All right, so we're done with today's notes.